Alright, the new camera is installed and I would like to test the volume. I want to make sure that there's no echo in the room, which I've had with the other ones, and then I'm going to try a couple other things a little later on today. Let's do this. Let's make sure we can get the stuff from the PowerPoint. Okay, let's watch this video. This is transcription and translation. So first we got to zoom into our DNA, which is coiled up in chromosomes. See all these chromosomes. And I'll put this website in the description, so I'm going to throw myself into the video so you can see what's going on. Helicase unzips DNA. It's going to break those hydrogen bonds. Here's the first thing I want to draw attention to my students. See, here's your complementary strands of DNA. DNA A to T. And then later on you're going to see, you see these free nucleotides, you'll see, let's do it. Watch this one right here. Wait for it. Okay, A to T are going to reconnect. When DNA separates, it's only for a short moment. The DNA to RNA, that's called transcription, that's only going to do a couple bases at a time. Look at all these bases. All right. Now remember, every 3 letters of mRNA is called a codon. Every 3 letters of DNA, some people call it codon, but I like to say triplet. So how do you know the difference between the C and the G? That's DNA versus RNA. Let's take a look. The sugar, ribose sugar versus deoxyribose. All right, we'll let this play a little. And by the way, this is a really good website. I will put the link if you want to practice. And one of the things you'll see later is I can do, I can change the DNA. I can do a whole bunch of different DNA sequences in there. So, hey, DNA is going to zip and twist back up. The enzyme that did that was RNA polymerase. If it was DNA, it would be DNA polymerase, and it would be making 2 new DNA molecules. Messenger RNA leaves the sequence. Now, let's get myself out of the way. I'm going to pause when the first thing comes in. All right. This is a ribosome. Here's this messenger RNA that was just transcribed. DNA is replicated. DNA is transcribed. Okay. RNA is translated. And the product is this. This is actually phenylalanine. If you had a codon chart, you could open that right now and look in UUU, and you would see phenylalanine. This is the 1-letter abbreviation for it. This is a codon. Now what I want to do now is test, see if I can write on this website. So here's your codon. Here is your anti-codon. Okay, this is the AA. All right, here's your ribosome. This whole thing is mRNA. This is T. I should do it over here so you can tRNA. And again, my handwriting is really bad. All right. Now, if I can't hit play because the screen's frozen, so the writing is going to go away. And let's hit play. When this is done, we'll see what happens. And now, let's zoom back out. mRNA is done. Actually, mRNA is not done. The protein's forwarded. Each one of these little green dots is the messenger RNA. This is a panning out, so we zoomed in. These are the amino acid sequences. This is the messenger RNA. This is the ribosome. And what happens is ribosomes just kind of run down and read. That's the word that we use. They read or translate the mRNA, and you see the messenger RNA sequence. There's some really good videos that I have on my playlist that I didn't make, but you can watch. They're pretty good. So, all right. Now, I want to see how the volume worked on this, and I'm going to do a couple other things.